Today we are going on an extraordinary journey through space and time to unravel the formation of the solar system and planets. Get ready to witness cosmic spectacles and the birth of celestial bodies.
Our cosmic adventure starts billions of years ago within a colossal cloud of gas and dust, the solar nebula. No, not this nebula. A nebula is a giant cloud of dust and gas in space. Some nebulae come from the gas and dust thrown out by the explosion of a dying star, such as a supernova. Other nebulae are regions where new stars are beginning to form. Deep within this cosmic cloud, something extraordinary began to take shape. It was akin to the Big Bang moment of our solar system. It is the formation of our star, the Sun. But our solar system story doesn't end there. Each of our planets has a unique tale of formation, like chapters in a cosmic book. Our first chapter introduces us to Jupiter, the king of the gods in Roman mythology. Jupiter is the giant of the solar system. It formed early on, its colossal presence shaping the destiny of our celestial neighborhood, munching on the materials needed for a planet formation. Not the colossal you are thinking, but still shaped the way. Next up, Saturn, the lord with rings. Saturn was named after the Roman god of agriculture. Saturn joined the cosmic party, its rings and icy beauty emerging as it danced around the sun. The Grand Tack hypothesis says that Jupiter formed at a distance of 3.5 AU from the Sun, then migrated inward to 1.5 AU before reversing course due to capturing Saturn in an orbital resonance, eventually halting near its current orbit at 5.2 AU. So we need to thank Saturn for giving us space for our existence. Next to the Uranus and Neptune, Uranus is the ancient Greek deity of the heavens, the earliest supreme god, and Neptune was the Roman god of the sea. The icy siblings, but not quite. Neptune's rotation axis, 28 degrees, is quite similar to Earth's, whereas Uranus rotates on its side with its axis almost parallel to the ecliptic plane. Neptune is a vibrant shade of cobalt blue, whereas Uranus has a pale green tint. 4 billion years ago, Uranus and Neptune switched places during a gentle ride out to their current orbits. Finally, closer to our radiant sun, the inner planets took shape, with the remaining particles left after the Jupiter's rampage. First, Mercury. Then came Venus, Earth, and Mars, each with its own cosmic story. Our first planet, Mercury. Named after the swift messenger of the ancient gods, it is the smallest planet in our solar system and also closest to the Sun. Because of being so close to Sun, its temperature can go up to 450 Celsius, and at night, minus 170 Celsius. Yes, cold exists on Mercury. It is because it does not have an atmosphere to hold the heat within it. So the next planet, Venus. Named after the Roman goddess of love and beauty, because of the bright, shining appearance in the sky. But beneath the planetary cosmetics lies the true nature of it. Venus has a thick, toxic atmosphere filled with carbon dioxide, and it has yellowish clouds of sulfuric acid that trap heat from active volcanoes and sun, but does not allow it to radiate out, causing a runaway greenhouse effect. Surface temperatures on Venus are about 475 Celsius, hot enough to melt lead, which makes it the hottest planet in our solar system. Moving on to Mars. Mars is named after Roman god of war. No, not them. Mars is a dusty, cold desert world with a very thin atmosphere. Mars is also a dynamic planet with seasons, polar ice caps, canyons, extinct volcanoes, and evidence that it was even more active in the past. Olympus Mons is a large shield volcano on Mars, the biggest volcano in the solar system. It is about 2.5 times Mount Everest's height above sea level. The rocks which cannot be successful in their journey of becoming a planet are left between Mars and Jupiter, known as asteroid belt, and the others are so left on the edges of solar system in the region called Kuiper belt. Pluto is still out there, but the International Astronomical Union downgraded the status of Pluto to that of a dwarf planet because it did not meet the 3 criteria the IAU uses to define a full-size planet. Essentially, Pluto meets all the criteria except one. It has not cleared its neighboring region of other objects. Now, if you are still waiting for the last planet, and there you have it, the breathtaking saga of the formation of the solar system. If you found this journey as captivating as we did, be sure to hit the like button and share it with fellow mates. Don't forget to subscribe to Ample Quasar for more fun content and everything you love.